Hi, good evening, sir.
Okay, good afternoon, students. I trust that you're doing well. You had a good weekend and you're ready to go. I'm giving you a warm-up question. Um, I want you to find all six of them for me. The first order partial derivatives and the second order cross partial derivatives. So I want you to find f subscript x, f subscript xx, f subscript xy, f subscript y, f subscript yy, f subscript yx. So go ahead with those calculations for me, please. All six of them. I'll be back.
sir. Good afternoon.
Good afternoon, Harry, how you doing?
I'm good so far. Sir, I came a bit late, so I didn't hear the instructions. Is it that we should do the same as
Yeah,
what we
man.
did last class?
Yeah, man. I want you to find f x, 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 y, 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 x. All six of them.
Okay.
Yeah, cool.
Sir, could you just repeat, or if anyone is here, the last two, X, Y, X?
No man. F subscript X, F subscript XX, F subscript Y, F subscript YY, F subscript XY, and X subscript YX.
Oh, X, Y, and Y, X.
Mm-hmm.
Oh, okay, okay. Thank you, sir. So, sir, you just giving us some time to get the answers, or we should send it to you?
I'm gonna go through them. I'm gonna go through it and
Oh,
in front of you. I know people are still coming in at this as we speak. Just somebody just came in.
Yes,
Am I
sir. Can you
to
stop sharing and resharing your screen because it's just blank for me at this point, please.
well, I'm seeing the screen, but it don't
Okay, yeah, I'm
change.
seeing it now, sir. Thank you.
Oh,
All right.
okay.
I was gonna say something. All right. It's now 7:20. 7:25. It's now 5:25. Um, for those of you that are finished with that question, I am gonna I'm gonna give you 5 more. Give those of you who are just coming in 5 more minutes to do the question. Take off that off the screen for me, please, because I'm gonna put on another one. So those of you who are finished, instead of you sitting and waiting, you can just work on another one for me and see if you can finish this one in 5 minutes. I'm
All right,
gonna. All right, good.
all right, yeah, no problem.
All right, so see there now. Try and see if we can finish that one. So I'll just go through both of them. For those of you who have only done one, I'll just go through that one with you.
All right, thank you.
Good.
So we did forget some homework or something, because we get a message today, you know, ask if we send some homework.
Right.
When,
I should have sent some stuff for you, but Wednesday, when I left you guys, I went straight into class up to 10 o'clock.
yeah, so
And
possibly.
pop
Sir, when
down,
is mid-semester?
pop down. And then we had the Jamaica Day celebrations, and I was up and center and all of that. So I really got tied up in all of those. So I have the
Oh,
questions here. A matter of fact, the questions that you're doing now are a few of the questions from what I should have sent. So we're just going
okay.
to spend some time now and just go through those, and then I want to move into I want to compound it a little today, guys. I just want to get our feet wet somewhat with the first order partial, the second order partial, and the cross order partial. So I may
Mm-hmm.
do about 2 more, then I jump into the past papers, and then I jump into another era of which is the final era under the stationary point for this. So just 3 more minutes and then we'll come back.
So because you said somebody that asked when is mid-semester, because we're supposed to have one today for our next class, so maybe that's why.
What time are you? You see, my mid semester have to be coordinated, because my mid semester is going to be done face to face. So
Oh, okay.
I'm not doing a mid semester that is
Okay, sir, no problem. That sounds good.
all right. Big
We
up
can
yourself.
vote. That sound like a poll. Like we have to vote based on everybody's availability and all that.
Oh no, it's a given.
No,
It's a given.
it's a given.
It's a given.
Okay, sir. All right.
Yeah, but it's a given. So what I have to do now is I'll have to coordinate with the person that which class do you have after this?
We have Java,
With whom?
Mr. Parchment. That's computer programming 3.
All right. And then now tell me, and the BDIT and the A and the BMIS have the same courses, or you have a different course after this?
I would say
No,
well,
BDIT and MIS are different courses.
Okay,
Well,
so
I'm the only AMIS person, the BDIT person.
what you have Damoy
I don't
after
have
this?
anything after this, sir.
Oh, so you're free.
Yes, sir.
Okay, all right, good. So you are okay then. So and then on Wednesday now, what class do you have on Wednesday?
Oh, I have two separate classes, sir. So it's um system admin and cloud computing.
So you have a class
No, I just have those two classes.
in the evening? You have 3 classes in the evening?
No, just two classes, two classes.
Oh, so what time? I know you have me at 5 to 7. What do you have at 7 to 9?
Oh, it just on Wednesday.
Yeah.
Oh no, I just have calculus. Come here, class, sir, and project management. Never mind.
Okay. All right. The BDIT, what do you have on a Wednesday?
Your class on project management, sir.
Oh, my class, I'm project management. All right. BMIS, what do you have? Who teach you project management, by the way? Good morning.
Russell Francis.
Russell Francis.
Russell.
Oh, Francis. Yes. Russell. Okay. All right. All right. So BMIS, what do you have on a
Sir, it's the same
Monday?
thing.
You and computer programming, sir.
Oh, so you have Java after this
Yes, sir.
department, and then on Wednesday you have Russell.
Yeah, and you. Yeah.
All right. The reason I'm asking is that I have to coordinate with those lecturers. Because since I'm going to call you guys in, I have to coordinate with those lecturers. So both of them and I have a good little something, so I can have to coordinate. So I'll let you know. I'll speak with them. That's doing Patrick and Francis Vassar. I will speak with them both, and then we can coordinate. So I have to do it from that line. If not, I may have to call it in on a Saturday, and I don't want to do that because I know people going to me that they're Adventists, all of them now go to church. So I'll keep you posted. All right, continue working on that for me, please. 2 more minutes.
Sir, when I reach out yet still, Yeah, traveling I do.
Try to keep one eye up on the road here.
And I'm here drive, sir.
Praise the Lord. No, but the driver, I forgot in my class too. The driver forgot to do the work. So tell the driver, say, make I do my work.
Okay, sir. I try to chat.
All right. In the chat, I see what is posted there. All right. All right, let me go to the first question. All right, so you know what I'm going to do? Now coming to you, Andrew, I am going to just some posting my solutions for the first question. F subscript x and x, y, 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 x, y, and y, x. Tell me if you agree or where do you disagree?
Agree, sir.
Very nice.
Yes, agreed, sir.
Good job.
Agree, sir.
Nice. I heard that from about 4 people. Guys, let me know, please. Let me know. I don't want to assume that you are understanding. And when I move into my stationary point question, people are box shuffling. You're going to be
Agree,
on your
sir.
phone. All right, good. Who else?
Agree, sir.
Good job. Who is this iPhone person? Identify yourself, please.
Sir, that's me. Sorry.
Okay. You're here twice?
Yes, sir.
Okay. What's my phone here? The rest of you? Okay, I'll soon tell about that one. All right. Here's Raji. Anybody know for Raji? I had this Raji come to class in. Oh, Jesus. Students in the can't play with the calculus course. It's a rough course, and you can't play with it. I was going to say something. For those of you that have not heard from, am I to assume that you are okay? No, but hold on. Classes. Wednesday. Yeah. Wednesday, that's the come. All right, I'm going to ask this question one more time. Students, you see, when I get to my stationary point and I'm ready to move, all I'm going to do now is project my function, and then I'm going to move from my function. I don't want anybody to say to me, sir, I don't know how you get that again, sir, because I'm giving an opportunity now, and I've heard about from 4 students, and there are many more than 4 of you here. I'm asking you one more time. Are you all okay with this? The ones that did not answer me, are you okay?
Oh, yes, sir.
Okay.
Yes, sir.
All
Yes, sir.
right.
Put it as sir.
Now, I need a volunteer for the second question. All right, I want a volunteer to do that question. Away from you, Carno, I don't want to hear from you. I need a volunteer for F subscript X and F subscript XX, please.
So I can volunteer for that.
For the
Good job, go ahead, Taj.
Alright, so for f subscript x, we're looking at 4x y squared plus 6y plus 1. For f subscript xx, I'm looking at 4y squared.
Is he correct?
Yes, sir.
Yes, he is. Very nice. I'm proud of you, sir. Hold on there. What name does I recognize this? Up here, man, living in the clothes. Where's Ugaman? Barrett gone. I'm seeing him come back. Alrighty. Dijon, what you get for f subscript y, f subscript y?
For the second question that you gave us, sir.
No, not you, Dijon. Yeah, but the second question, yeah. Anderson. F subscript y, f subscript y.
What I mean, sir, but the answer them that one they think.
Hmm?
Is maybe my join late, sir. Is this number two you're talking?
Yeah.
Is the same thing we have on the
No. This was the first one that he gave us. It's just that it have the name number two. He gave us
So
a
this,
third
so this,
one.
the second one, Dujan, would be number 3.
Yeah.
Well, this is the only question I saw, sir. I didn't see the other one.
That's $1,000. All right. So who should I call? All right, Andrew, let me hear. You're not driving, so let me hear what you have. FYY, Andrew. All right. Mendez, go ahead for me, please.
Yes. So they want Fy and Fyy.
Yes, I.
Sir, that's 4x squared y plus 6x plus x for Fy, and Fyy is 8xy plus 6 plus 1.
Is he correct?
Wait, say that again, Terry?
Almost.
Alright, so Fy more 4x squared y plus 6x plus x, and then more 8xy for Fyy have 8xy plus 6 plus 1.
No, that's not correct.
Okay.
Alright, that's all.
Let me check how more then.
Sir,
Yes, man. I'm waiting on you. Actually, no.
sir, were those the answers for the second one?
Yes, I.
Oh,
So we got the correct answers for fx and f subscript x and f subscript fx. I'm waiting now for f subscript y and f subscript yy. So finish f subscript y, no, Tariq? You were actually closer with f subscript y than you were with f subscript x. I mean yy. And
Oh, is y?
and you're making a big mistake with yy. But I won't tell you what.
Let me check. So the so the fxy is 2x squared y squared plus 6xy plus.
Are we going over this? We need
No,
for this.
so we want to find out if we right on the right thing for the
No, but you see
question.
that's the point I'm making. So I'm
Oh,
saying to you, you got those answers to be the same thing for the f subscript x, y, and yx.
yx. The
You got the
yx.
same. You got the same answer for x, y, and yx.
Yes, sir.
Mm-mm.
Yeah.
Focus
Wow.
on focus on focus on f subscript y, and then tell me what you get. F subscript y.
F subscript y, I get 4x squared y plus 6x plus x. That's right.
Sorry about that.
No, that wrong. Sorry. 4x squared y plus 6x plus 1.
That is not correct. Do you agree with him?
Yeah. Yes, sir.
Yes, sir.
And
All right.
then
So
and
now
then
tell me what is y.
yy is 4 no is 8x. Wait there. So give me a second there. Just look at this correctly. Next one is 4x squared plus 6. No, it's
No.
4x squared by itself. Sorry.
Yeah,
That's right.
correct, man.
4x squared by itself. All
Yeah.
right. So we need to sharpen up our skills. No, you're correct. I'm happy that you're able to find your errors. You know, we need to shape up and sharpen up our little skills in that regard. All right. Let me see if I can find. There were some questions, you know, that I thought I had saved, but I clearly didn't. All right, no problem. I think I may. Yeah, all right. Let me just do this one. Or these. Help. Additional practice questions. All right.
Sir,
All right. Yes, please.
sir, I would like for you to just run over quickly for me for the XY and YX. For even just for this one, that's on screen right now. I would, yes. So that's
Oh,
exactly what I want. I hadn't.
okay. Yeah, but guess what? No, I'm happy that you asked, because I never asked the question. I never asked for X, Y, and Y, X. I was
Right.
actually trying to find another question. All right, no problem. Sure, we'll do. Shane, are you back? All right, Kahim, not waiting, you know.
Yes, sir.
All right, do me a favor. What was your XY and your YX?
Sir, man. Oh, um, 8xy plus 6.
For which one?
Sir, for both.
Correct, sir.
Yeah, very good. If I say it, you know, I can't now assume say.
Sir, we know it's for both.
No, you know it's a you know it's a both. Oh, I'm not going to check. I'm not going to assume. You have to say for both, sir. All right. So yes, for both, it's correct. If you get your XY and your YX to be anything different from mirroring themselves, you are wrong. Anything you get from mirroring yourselves, from mirroring what is happening there, you are wrong. So look at what is happening, as is requested by Taj.
So I can actually see it in this one. So
Well, if you see it in this one, Papa, you see it in all of them.
true.
Yeah.
For some reason, it jumped out at me.
All right. But nonetheless, you see, because I was still prepared to go through it, there's somebody in the class that you asked for, but that is not unmuting. There are a few of them I called tonight and they don't answer me. So let me just run through it nonetheless. So we're doing F subscript X, Y. I'm first looking at F subscript X, which is this, and I'm differentiating with respect to Y. When I differentiate with respect to Y, my 4x is constant. When I differentiate Y squared, I get 2Y. So 2 times 4 is 8, so we can get 8xy, which is here. And when I differentiate the 6x with respect to y, probationist, when I differentiate 6y with respect to y, I'm going to get 6. My differential of this constant is 0. Similarly, to find yx, I'm going to find the derivative f subscript y, f subscript y, f subscript y, right here. So and then I'm going to differentiate it with respect to x. And when I'm differentiating with respect to x, the y is constant. When I differentiate with respect to x, 2 times 4 is 8. So I'll have 8xy, 8xy, good. And differentiate my 6x with respect to x. I'm going to get 6. And then this is how I get it for both. So this is why this is called a cross-order partial. Cross-order partial. I'm trying to find a past paper question. I know the same one that Tariq alluded to earlier. I remember seeing a past paper question on your paper, on your exam, past papers. But anyhow, is everybody seeing what is happening here? Are you understanding?
Yes, sir.
All right. All right, I'm gonna round some questions, and I'm gonna give a few minutes to do them. And I'm dubbing those additional practice questions. I'm giving you 5 minutes each. 5 minutes each, because the next thing now is for me to move into the other aspect of the calculation. 5 minutes each.
So it's the same thing, right?
Yeah, man. Obviously,
Getting along.
Yes, sir. Finish.
finished. Good job. Everybody is finished. The more you say getting along, how far you reach the more?
The fx,
FXY?
fxy, yes, sir.
All right. 1 more minute. I'm tired. Up and down, man. All right. Talk to me about F subscript X. Anybody? F subscript X answer is
2x
xy
y
to
to
the
the 4th.
fourth plus 4y squared.
all right. Thanks, Connor. Somebody say XX.
So for
2y to the 4th.
2y to the fourth.
Thank you. Somebody else for X for FY.
FYY?
FY.
Oh, for FY. FY, I'm looking at 4x squared y cubed plus 8xy plus 21y squared.
Is he correct?
Yeah.
Yes,
Yes,
sir.
sir.
Very good, Taj. Very good. Somebody else for YY.
12x squared y 12x squared y squared plus 8x plus 42y.
Is he correct?
Yeah. Sir.
Thank you. Thank you, correct. Somebody else for XY.
So xy, I'm looking at 8xy cubed plus 8y.
Yeah.
Yes, sir. That's correct.
Very good. Love it. All right. Next 5 minutes.
Uh, Sir, we're not seeing the question.
Yeah, no. I had one here, but it was too easy. So
Then give it,
I
sir.
changed. No, I'm changing it. Too easy. That's for people who just learning the topic. I run the one now. All right, so you guys ready for me now with that one?
Hold on, look at this, sir. Look at that. They're the last two.
Finish, sir.
All right, 1 more minute.
Yes, sir. We finished. Anything private or
No, we're going to talk about it publicly.
all right.
Give me your X and XX, please.
My one?
Yes, sir.
All right. My x is 2x minus 12x cubed y fifth plus 3x squared y squared minus 4y xx 2 minus 36x squared y fifth plus 6x squared 6xy squared.
Is he correct?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes,
All
sir. Yes,
right.
sir.
Very nice. I'm happy. Very nice, Papa. All right. And then I am going to be calling upon Shane. This is my second time calling upon you.
Yes, sir.
F subscript Y and F subscript YY, please.
Sir, before I can ask a question,
Go ahead.
um, for the FY, it's okay to have my answer that I got for FY is negative 15x4 y4 plus 2x 3y minus 4x.
Correct.
The negative is
Yeah, okay with the negative.
and for y is negative 60x 4 y3 plus 2x3.
Yeah, correct.
All right. Very good. You over there doubting yourself in a Shane. You notice I didn't answer you because you're over there doubting yourself. So I'm going to answer your question before I give you the answer. Just tell me the answer, man. I can tell if you're right or wrong, and we can sort it out after. Stop doubting yourself, Papa. You're doing well. All right?
Yes, sir.
Andrew. X, Y, Y, X. All right? Roger, X, Y, Y, X.
Yes, evening, sir. For mine, I have 2x minus 12x cubed, 5x, sorry, 5y to the 4th.
Sorry. Which one are you doing, sir? 5y to the 4th. 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 5y to the
FYYX, sir. The last two.
Yes, sir. Go again.
I have 2x. 2x minus 12x to the third.
What I asked,
5y.
what I asked you to give me, Raj?
Cross order, partial derivative.
Right. So why are you giving me S subscript X? I want you to give me XY and YX. Don't give me X subscript X. That's what you're giving me.
Oh, my bad, sir. I never finished. I was not finished. I'm gonna get an
Okay.
incomplete answer.
Damoy, help him out, please.
The last one, right?
Hmm.
All right. So the last one is negative 60x cube y to the fourth plus 6 6x squared y take away 4.
Is he correct? For both?
Yes,
No,
sir.
for both. Let
Okay.
me
Yes, sir.
establish that.
Correct.
Okay. Thank you. You see, I have to ask if it's about, because some students do get different answers. And guess what? What is also important is some students don't listen to instructions and they will only do um, XY and then just go back and write on the same thing for YX. And that could be wrong because if you made a mistake in the top one and look at the bottom one and recognize you get the same answer, it can save you from getting 19 out of 20 or 18 out of 20 to get 20 out of 20. So always calculate both. Don't just calculate one and then write down the answer for the first one in the second one slot. Yes, we know it's going to be the same, but I want to write it out and work it out. All right. I think you're doing well. Uh,
Sir, could you tell me the answer for the number 7 FYY?
8xy cubed plus 8x, 8y.
No, sir. That's for XY. For YY.
FYY, that was 12x squared y squared plus 8x plus 42y.
Correct.
Okay.
All right. For the most part, I believe you guys are now ready for the grown-up calculations. I think you guys are ready for the grown-up calculations. And at 17 past 6, I'm beginning my stationary point. And we're going to calculate. Read the first three for me, please, and then I'll go over it with you. Read the first three.
Sir, as in out loud?
No man. Read to yourself and see what you can get from it, and then I'll go and explain.
Okay, sir.
All right. I think I've given you enough time to read through, as I did for stationary single variable functions, stationary point for single variable functions. I'm going to be doing for you with the multivariable function. Now, to determine the stationary point, now hear me out. Why I'm so very pleased with what is happening and deliberately asking you to speak to me with solutions. This is a very new area, a fresh opportunity to catch up, a question on the exam, a full question on the exam paper for 30 marks on this area. You have other opportunities to pick up another 10 marks or so, could be 5, on another area of this multivariable function. And yet there is a third area. So why I'm so patient with you is that I want to build your confidence in doing this topic. So if anybody I'm losing, stop me. To determine the stationary point 1, we're going to differentiate the multivariable function x comma y. And we're going to be obtaining values for f subscript x of xy and f subscript y of xy. Were we doing that?
Yes, sir.
Yes,
All
sir.
right, good.
Yes, sir.
So we know what it is that we're doing. So,
Sir,
yes, sir.
could you say that again, please?
I'm saying to you, the first one, to differentiate the function f subscript xy, f of xy, we need to obtain f subscript x of xy and f subscript y of xy. So I was asking the question, were we always doing that with our calculations?
Yes, sir.
Good. So that is the first step that you need to do in preparation of our stationary point question. The second step is you're going to set the differential equals to 0. Blow, sir, what do you mean by that? Same thing like the single variable function when we set dy by dx equals to 0. Now remember, our first derivative is f subscript x and f subscript y. We're going to set those differentials equals to 0. F subscript x of xy equals 0 and f subscript y of xy equals 0. And then we're going to solve the unknown simultaneously or otherwise. So when I say otherwise, meaning it's still a simultaneous solution, but you are going to do a substitution of one thing compared to the other. And then, when you solve those, that will give you your critical values. Critical value or critical values, stationary point or stationary points, so forth and so on. And then the third thing is that the result yield the stationary point or critical point or turning point. Remember that all mean the same thing. And it's going to be written in the form A, comma B. So all you're doing now, or will be doing now, it's similar to what it is that we did for single variable function. And I know some of you did very well on the single variable function. To classify the nature, and this one is a tricky one. Suppose that AB is a critical point of x comma y, and that all the second order partial derivatives are continuous in some region. We're going to be using this formula. This formula is something that you must know. D of AB all of that is going to be equals to f of xx times f of yy minus f of xy all squared. Watch me. Look how easy it is.
Yes, sir. When I tell you, sir, that's very just foolish until you say example.
No problem, Papa.
Sir,
And I
I see the
appreciate that.
formula.
Oh, you ready to talk to me now? Well, let me call upon you. I have 2 times call you and you're not answering me.
Sir,
You know?
may I travel? May I tell you, sir, I wasn't hearing anything, sir.
F of xx times f, this is a times. F of xx times f of yy minus f of xy all squared. Now watch it. It is f of xx AB, because AB is a critical point. Now remember, when we're doing stationary function for single variable functions, to classify the nature of the critical points, we substitute our critical values into the second derivative. Talk truth.
Yes, sir.
Yes, sir.
So it's the same thing we're doing here. X is my second derivative. Y is also my second derivative.
Yes, sir. I see it. And because x, y, or y, x with IP, the same thing, we just use one and square it.
Good job. Good job.
Yes, sir. I see vision now.
So it is f of xx AB, my critical point, times f of yy, my critical point. When I put my critical point there, AB, it means that I'm substituting my critical point into the function. Minus f of xy of AB all squares. This is it now. If D, the one here, is greater than 0, and f of x, the value of f of x that you evaluate here, so is also greater than 0, then we have a relative minimum. Let me go again. If when you evaluate everything and D comes out to be positive, I forgot to check your f of xx. Because if f of xx is also positive, then you have a relative minimum. Look at number 2. If D is positive, like the first one up here, so. But f of xx is negative or less than 0, then we have a relative maximum. Are you clear?
Yes, sir.
Yes, sir.
No, if D is less than 0, we have a saddle point. You're not going further. You're not check nothing. So if when you do your stuff and you get Z to be less than 0, just tell them, say, yo, saddle point here. Are we good? Hello?
Sir, say it again.
Yeah, that's okay so far, sir.
Okay, all right. I was just asking if everybody is good. All right. So last one now. If when we evaluate it and D comes out to be equal to 0, hear this. So we may have a relative minimum or a relative maximum or a saddle point. I don't know which is which because other techniques must be employed in order to classify the points. So that's it. If when you evaluate it, D is positive, you have to look at f of xx. If f of xx is also positive, you have a relative minimum. Look at f of f subscript x of yy. If D is positive again, but f of xx is negative, you have a relative minimum. If D is less than 0. And if D is equal to 0, technically it can't work. Let me know when I can move into an actual example so you can see this in real life.
Yes, sir. Go ahead.
All right. I think maybe just one question in class on this to give an idea as to what can come. Can you see my screen?
Yes, sir.
Yes, sir.
Mhm. Find and classify all the critical points for that function. What's the first thing you want to do?
Obtain f
Find f of
subscript
x of
x
x
F
and
of X
and
and
y.
f subscript y of x and y.
Very good. So how many calculations supposed to have in total?
So
2.
Okay. And then what are we going to do thereafter?
make them equal to 0
And then
0.
and find a critical point.
on the mark gets it go. Please let me know when you have done the differential and set it equals to 0. Matter of fact, I think I asked a question. I want to get piece of the answer. Not to think of it. I did ask how many calculations are we supposed to be doing in total?
Sir, 3.
No,
It's
Four.
not 3.
no.
I think
We're supposed to
yeah,
find
4 or 5,
x.
sir.
We're supposed to find x, y, y, x, y, and then the the function, the
6.
All
yeah, the thing
6
that
of
you
them.
are.
You must find all 6 of them. Because
So it's
remember, you have to use the classification. When you're classifying the nature of the critical points, you're going to be using your fxx times fyy minus f of xy all squared. So get all the differentials out of the way first before you do anything else. So you have to find f subscript x, f subscript xx, f subscript y, f subscript yy, f subscript xy, f subscript yx. But when you find all of those now, the next step you're going to do is to set f subscript x equals 0 and f subscript y equals 0. Please and thanks. No, man, not take too long, man. We're not finish the 6 calculation yet.
Sir, who said we weren't?
Say it again.
So I'm saying, who said we weren't?
Okay. But how would I have known? If you don't say finish, sir, talk to me.
Finish, sir.
Finish, sir.
Oh, yeah. No, me no finish.
Sir, I didn't
All right.
say we were.
Hey, boy, if you work on do something, you know, come in, know you understand what going.
Finish, sir.
Yes, sir. Finish, sir. We'll distracted a bit.
Okay. F subscript X is
6xy.
6y minus 6x plus 2.
huh?
F
Sir,
of x
omit the
is
plus 2.
6xy minus
Oh, yes,
6y.
sir.
6x, sorry.
6xy
So
minus
6xy minus 6x.
Okay.
F of
6xy minus 6x. All right, good.
Yeah.
I agree with that one. F subscript Y.
3x squared
Yeah,
plus
plus
2y
2y
minus
minus
6y.
Everybody agrees with that?
Yes, sir.
Yes, sir.
Shane, I need to hear you. Raj, I need to hear you.
Can you repeat it again,
Um,
sir? For
3x
F of-
squared plus 3y squared minus 6y.
Oh, yes, sir.
What is F subscript XX?
6y
Plus
minus
6y minus 6.
Excellent. Very nice.
What answer, sir?
Yo. Go ahead, Andrew. Him not hearing us. Go ahead.
sir?
Somebody says, sir, me what?
No, Andrew, the same that way as in the ask way as sir.
I know, but I mean, I was responding
Sir,
to
f
him. But
of x is 6xy plus 6x, let's say.
F of x is 6xy minus 6x.
Yeah.
F of y is 3x squared plus 3y squared minus 6y.
What do you have for F of XX, Andrew?
Sir,
Hmm.
6y. 6y minus 6.
Is he correct?
Yes, sir.
Yes, sir.
Yes, sir.
Anybody get F of YY?
Yes, sir.
Yes, sir.
What?
Yes, sir.
6y minus 6.
Mm. You see, F of YY can be the same thing as F of XX.
Yes, sir.
Yes, sir.
But they don't have to. Here goes something that must though be the same thing. What do you get for F of XY?
6x.
6x.
YX.
Same.
6x. 6x.
Look at my screen.
Yes, sir.
All right, so do me a favor now. I want you to set F of X equals 0 and F of Y equals 0. And we're gonna try and solve them now simultaneously.
Yes, sir. Do that for sir.
Good job. Anybody else? Come talk to me now. They have less than 20 minutes. Come talk to me.
Doing so now, sir.
Repeat,
Right.
sir.
So for critical point, dy by dx is equal to 0. Dy by dx is equal to 0. What's dy by dx? My first derivative. What is my first derivative in this question? It are my first order partial derivatives. My first derivatives are my first order partial derivatives. As I told you last time, when you have one subscript, it means there's only one differential to do. When you have two subscript, it means that two differential. So the xx and the yy are second order partial derivatives for x and y. For the yx and xy are second order cross order partial derivatives. Watch me. So therefore, I'm going to let this 6x minus y, rubbishness. 6xy minus 6x to be equal to 0. And 3x squared plus 3y squared minus 6y to be equal to 0. See it here? Boom. A linear equation. Well, it's not really linear. It's actually non-linear because I have a xy. So this is non-linear. Okay. So I think I did something.
So just click undo, sir.
I think I deleted something, don't?
Yeah, you highlighted the thing, and when you were typing, it just stick to. Just
Okay.
undo it until it.
Right. Come on, got it back. Because I was wondering, I was looking at the stuff and I'm like, wow, something gone. All right, so I need to change here. So this is actually non-linear. And why is it non-linear? It's not a linear equation because it's not just 6x plus 6y. The first term is 6xy. So this xy here makes it a non-linear equation. So what we have is 6xy minus 6x equals to 0. I color coded it for you because I wanted to see what I was talking about. You notice that what I color code is the 6x from this first term and 6x from this term right here. So it means that 6x is common to both. So when I factor out 6x from the nonlinear equation, I'm going to have 6x in open bracket. See? 6x is common. 6x is common in the first term, which is 6xy. It is also common to the second term, which is 6x. I'm factoring out 6x. I'm factoring out 6x. I'm factoring out 6x. I'm factoring out the 6x's. See it here, so. Work with me. When I take up the 6x from this side, what do I have left? Y. See it here, so. 6x into 6x goes how many times?
1 times
1. So that's why I had a minus 1 right here, so equals 0. No. Either this 6x is equal to 0, or this y minus 1 equals 0. See them here? If 6x is equal to 0, it only implies that x is 0. If you have 6x, in order to get 0, x must be equal to 0. Similarly, y minus 1 equals 0. And you add 1 to both sides, you will get y equals 1. So I have an x value here, and I have a y value here. Now watch the sequence of the stuff. These are my critical values. Always factor and resist the temptation of canceling the x's, them one here. Some students may say, oh, let us divide through by 6x. That will cancel the 6x, you cancel the 6x, and we can have 0 over 6x, which is really 0. So what you'd have had up here is just y minus 1 equals 0. which technically is this. And then you'd have lost the values for this one. So you wouldn't have gotten any x equals 0. All right. So you need to resist the temptation of canceling. I know lots of students love to cancel. Resist that temptation. Please also note that it is not the critical point. These are critical values. How many times you hear me say that?
There are enough
A
time for
lot,
you to
sir.
understand.
Enough times for you to remember. Enough times for you to remember. Don't. I can't use equation 1 again because I use equation 1 to get these values. So we're now going to be forgetting about equation 1 and use equation 2. So anywhere in equation 2, I see x, I'm putting 0. See there? Anywhere in equation 2, I see x, I'm putting 0. 3 times 0 squared, see it here, plus 3y squared minus 6y equals 0. All of that goes to 0, so I'm just going to have 3y squared minus 6y equals 0. I'm factoring out
So
why do I
3
have
right.
this? Yeah, why do I have this minus here? Not supposed to be there.
Nope.
Right, I'm factoring out 3y. I'm factoring out 3y. Because 3y is common to 3y squared and 6y. So when I factor out 3y out of 3y squared is just going to give me y. Oh, sir, because when you multiply 3y by y, you're going to get 3y squared. 3y squared is the same thing as 3y times y. So if I take out the 3y, I'm going to have y left. And 3y into 6y goes 2 times. So I'm going to have y minus 2. Similarly, either 3y is equal to 0, which implies y equals 0, or y minus 2 equals 0, which implies y equals 2. Don't divide. Watch what. This is what I don't want to do. You see, when I reach right here, so I say 3y squared equals 6y, lots of students would have said 3y squared is equal to 6y. Add 6y to both sides to get rid of it right here, and then put the 6 out here. So to get this, 3y squared equals 6y. And then say, oh, we can divide by 3y because that is common. You're going to get y equal 2. You're going to technically throw away this value. And you can't do it. Are you with me?
Think so.
Yes, sir.
All right, good job. But now remember, this x equals 0 corresponds to these two values. So when x equals 0, y equals 0. When x equals 0, y equals 2. Don't it?
Yes, sir.
So the x equals to 0 goes for both y's. Why no, sir? Because I don't want to put into this one to get out these two.
Just to clarify something, the only reason why you only substitute 0 into 1 is because it's the only x value in there, right?
Why I substitute this 0 into equation what? What is it?
No, just to clarify something, the only reason is only one of them you substitute 0 in it is because it's only like one x value is there, which leaves you with the rest of the equation at the top.
I missed a question. I'm not getting the question. Ask me one more time, please.
Sir, he's referring to the critical points that we find above.
Up at the top
Which is
one, the
this.
first
Oh,
one.
above, sir, the first one.
The
First
first
one,
line,
first one.
the first line, not up there, sir.
Yeah, this one.
Yeah, that.
Not
Yeah,
the
this
first
one.
line, first line, sir.
First line.
Yeah,
Yeah, but
the 0 in the parentheses, sir.
Yeah.
Just clarifying, you only because it's the only x value there.
Yeah.
Okay.
Because remember, the values that we got up top here are critical values. So you have to go substitute this now in the function, the other equation to get the critical points. And then you're going to do the same thing for that one. So that's why I said to you, these value goes for both x and y. Watch me now. So yes, it's only one x. It's only one x you have there. So it's just one x again substituting. When we do that, we work out and get y equals 0, y equals 2. It went through the calculation just now. So look at what I'm saying. So my critical point is going to be 0, 0, which is x equals 0, y equals 0. And this 0, 2. 0, 2. X equals 0, y equals 2. Remember, we've got our critical values. One of our critical values is x equals 0. What we need to do with that x equals 0 is to substitute it into the original function to get into the original second equation, not the one that we use to get our critical values. And then when we substitute it into the second equation now, x equals 0, which is here, we're going to reduce it to a quadratic. 3x squared minus 6y, sorry, 3y squared minus 6y equals 0. And then we are solving. Now, similarly, you have to put this y equal 1 into the same function. You see there, that's equation 2. And you're going to end up with x squared minus 1 equals 1. So when you substitute here, the x's now will be, sorry, the y's now will be 1. The y's will be 1. 3x squared plus 3 times 1 squared. Yeah. Minus 6 times 1.
So can I scroll up and this is something, please?
Sure. Let me know if that's where you want.
Yeah, all right, thanks, sir.
All right, now. So we're doing the same substitution. And when we do, we're going to end up with something like difference of 2 squares. And then we're going to get our x equals 1 and our x equals negative 1. Similarly, we're going to have x equals 1, y equal 1, x equal negative 1 when y is equals to 1. So my critical points now are going to be all these. I'm going to have 4 critical points, sir. I never know I could have 4 critical points. We have to start them. 4 critical points. Any questions? And I'm stepping 1 foot further into this tonight. Any questions? All right. If not, make up yourself. All the best in a Java. I will talk.
Yes, sir. Respect.
Easy.
Sir.
Hey man.
Let's hear this.
Sorry, wait.